Hello, my name is Jay Chinaranga. Presently, I am pursuing my graduation in BTech first year in the Department of ECE. Now, I am going to represent my CAA-2 video representation according to the given topic, block diagram of an electronic instrumentation system. And now, let's get on to the topic. According to the block diagram of electronic instrumentation system, it includes some of the key stages which are followed by input or measurement stage with the sensors converting physical quantities into electrical signals. So if we are going to give the input to the system, it will be going to convert the input according to language that understands by itself. Okay, now that will be followed by the signal conditioning. The signal conditioning is a process in which there the input or the output will be modified, and next the signal processing stage enhances the signal through analog or digital methods. If the output is going to come, then we will be going to trace out the output using the analog or digital meters or the digital methods. And finally the output or the display stage presents the processed data to the users according to the some of the experiments that we are going to do in the that we have already done in the laboratories and etc. And now therefore we will be going to proceed to the block diagram. And this is the block diagram of an electronic instrumentation system. And in this one, first the primary term is going to be the transducer is a device which converts the which converts the physical quantities into the electrical signals, which will be understanding to itself. Okay, then next that will be followed by signal conditioner, that will be followed by scanner or multiplexer and the signal converter and so on. Now studying single terms will be might be difficult, so therefore we will be going to study according to the topics very inclusively. So therefore first topic is our primarily input or measurement stage. This is a stage which is very crucial in the electronic instrumentation system or the block diagram of the primary term. So which in because it takes the sensors, because it takes the inputs according to the given input by the user. So it will be taking the input, and it involves in the sensors or transducer that convert the physical quantities like a temperature, pressure and so on into the electrical signals. And there will be if we are giving the input, there will be types of sensors which will be going to take the input. And in that part, thermocouples or the transducers which measure the temperature accurately, not precisely, they will be reading the temperature accurately, and they will be converting the input into the electrical signals. Strain gauges will be detecting the deformation or the strain. Okay, next the electronic sensors which will be converting the pressure into the electrical signals. So there will be so many types of sensors or transducers according to the input that we are giving by the users. And our next topic will be signal conditioning. Signal conditioner will be the very crucial process. It is also very crucial after the transducers, because it will be going to modify the electrical signals which are coming from the transducers. Okay, signal conditioner is a crucial process in electronic instrumentation system that modifies raw sensor outputs to the accurate measurement. So if an input is coming, then it will be going to convert the information very accurately, so that it will be very useful to the user to understand. And this involves in three main operations. Amplification, which means amplification is a term which will be we frequently using in the studies, that will be going to increase the signal strength or increase or decrease the signal strength and so on. And it also filters the unwanted noise, as some of the earbuds or some of the headbands which are coming from the electronic devices. We will be going to see that features. And analog to digital conversion, ADC, if some input or if the sum of the output are coming from the input or the device, we will be going to detect that output from the analog or a digital meters, as we will be going to as we have already seen in the lab experiments. And the next term will be signal processing stage. Signal conditioning is different from the signal processing stage. So in the signal conditioning stage, we will be going to modify the our input or the output according to the user. In the signal processing stage, it will be enhancing the quality of the receiving signals. There will be modifying the input, and here will be the modifying of the quality of the signals, and it also involves in two main approaches: analog processing and digital signal processing. Analog processing includes techniques like amplification. Amplification means, I have already said that, to increase the signals or the decrease the signals according to the according to the output that will be used by the user. And modification and modulation for signal transformation, which will be going to be very crucial step in the signal processing stage. This is the main step in the signal processing stage. And DSP means digital signal processing will be going to convert the analog signal into the digital format. As we will be going to see, the digital format will be very precise, but the digital processing units will be very accurate in this present generation. And this will be followed by the microcontrollers or the dedicated DSP chips according to the outputs, or according to the inputs that will be going to the given by the user. And analog processing techniques, this will be followed after the signal processing stage. Okay, in this also there will be some of the methods which will be which are going to be amplification and filtering and modulation. This is also similar to the signal processing stage. So therefore I would like to say it briefly. Amplification means, which means increases the signal strength effectively, as I said earlier. Filtering, removing the unwanted noise and interference as per the latest technology, like earbuds or the headbands, which will be going to reduce the noise while we are calling, or we are talking to our relatives or some other else. And modulation changes the signal properties for the transmissions, which will be very clear to which will be very clear when we are talking and where we are communicating with others. And digital signal processing, DSP, as we talked in the as we studied in the signal processing step. This digital signal processing is nothing but converting analog signals into the digital format. As I said earlier, analog signals are very somewhat precise, but digital format signal, digital meters are very accurate to the present generation. Digital signal processing involves converting analog signals into digital format using analog to digital converters, ADCs. Microcontrollers play a crucial role in processing these digital signals, executing algorithms for tasks such as filtering, data analysis, and control systems, ensuring efficient digital processing, which will be very useful and a very crucial step in the digital signal processing, because it will be going to convert the analog signals into the digital signals. And it is very brief, as I explained earlier. And the output or the display, this is the final step. This is a very brief step, which means the output, in this also there were several methods, but we will be delaying them. The output or display stage is a crucial, as it presents the processed information to the output, to the users. As a computer, it also takes the input, processes the input, and gives the output. Simple. And this includes various output methods such as digital displaying for the real time, and the visualization, analog meters for straightforward readings, and data logging systems for recording and analysis. This will be very easy, and these methods help users understand the results of the measurements and facilitate further decision making. This is a very brief steps. And next we will be going to further. And these are the control systems, where if the output is coming, it will be controlled. Either it will be controlled, or it must be stopped. Otherwise the system which we have been invented or which we have been discovered will be damaged instantly. So we are going to use the control systems. And understanding the control systems, it adjusts the system parameters based on the output signals, which means according to the output signals, it will be going to the it will be going to adjust the system parameters according to the coming output. And it improves the accuracy and the stability. And it also closes the loop systems, because in resulting the enhanced automatic adjustments. And therefore the points has been written there. And thank you for watching this video. Have a good day.